Hey everybody, it's me, Mrs. Gomes, your friendly neighborhood math teacher, and today we're going to be looking at how to add mixed numbers. Now, if you remember, mixed numbers are made up of a whole number and a fraction. So we're going to be looking at how we can add those numbers together when the denominator is the same and when those numbers have denominators that are different or unlike denominators. Okay, so our first problem we're going to work with is 1 and 11/12 plus 7/12 plus 3 and 9/12. And we want to add those three numbers together. So the first thing I want to look at is, do we have the same denominator? Yes, we do. All the fractions have a denominator of 12. And therefore, this is actually very easy to add together. We're going to take all of the numerators of those fractions, 11, 7, and 9, and add all of those together. And then we are also going to look at circling our whole numbers and adding all of those together. So we have a 1, a 0, and a 3. And we're going to add those numbers together, which I did in green here. Okay, so when we add 11, 7, and 9, we get 27. And when we add our whole numbers of 1 and 3, we get 4. And so this answer is actually very easy to do. But I noticed that when I put 27 over a denominator of 12, the 27 is higher than 12, which then imposes that we have an improper fraction. So we need to change this improper fraction into a mixed number. And so 12 goes into 27 2 times, leaving us with a remainder of 3. And we put that over 12. Okay, so I'm going to make my 2 green because I want to indicate that that is my whole number from this mixed number. And I'm going to add that back with my other whole numbers, and so I get a total of 6. Okay, but then I notice also that my 3 over 12 is not reduced. And so I need to reduce that fraction. And after I reduce that fraction, it becomes 1 over 4, because 3 goes into the numerator 3 one time and 3 goes into the 12 4 times. And so my final answer is 6 and 1/4. And I circle it. Okay, we're going to move on. The next thing we're going to do is we're going to add mixed numbers with different denominators. Okay, so that means we have a whole number and a fraction together, but the denominator of the fractions are not going to be the same. Okay, so if you guys remember, the first thing I want you to look at when you're looking at these denominators is ask yourself, is one of the denominators a factor of the other denominator? Is one of the denominators a factor of the other denominators? If the answer is yes, that means you only need to change one of the fractions. If the answer is no, that means you're going to have to find the LCM, or the least common multiple, to change those denominators. Okay, so the first thing we're going to do again is circle our whole numbers, and we're going to add those two numbers together. So we have a 3 and a 4, and that equals 7. And then the next thing we're going to do is circle our denominator. So I'm now going to change my fraction, either of those numbers, 5 or 10, to a new fraction that has a denominator of 10. Yes, 5 goes into 10 factor of 2 times. And so I'm going to multiply that 2 I can actually keep my fraction 9 over 10 numerator, and I'm only going to change my fraction 4 over 5. So now I'm going to use my fraction 8 over 10 and 9 over 10, and I'm going to add them together. 9 over 10 plus 8 over 10 equals 17 over 10. Here we see we have an improper fraction where the numerator is higher than the denominator, and so I need to divide my 10 into 17. I get 1 with a remainder of 7 over 10. Okay, now we have another mixed number where we have the 1, and so I'm going to add that whole number of 1 to my other whole numbers. So 7 plus 1 is equal to 8, and I have my fraction, which is 7 over 10. My final answer for this problem is 8. and 7 over 10. And yay, you've just completed adding together mixed numbers with different denominators. Good job. Next, we're going to be learning how to subtract mixed numbers. Subtracting mixed numbers is very much like adding mixed numbers. Again, the only thing you want to remember is that you are subtracting, taking away. So we want to look at our whole number and our fraction separately. I noticed that with my whole numbers I have an 8 and a 2, and I'm subtracting them, and 8 minus 2 is equal to 6. And then I'm going to look at my fractions. I first look to see if my denominators are the same, and they are in fact the same this time. They are both 3, so I'm going to take my 7 and subtract my 1 to get a 6. So as I write this out, I notice that 6 over 3 can be reduced, and 3 goes into 6 2 times perfectly. And so that 2 is actually a whole number. So I'm going to take that 2 and I'm going to add it to the rest of my whole numbers. And so I have 6 plus 2, which is equal to 8. And so the answer to this problem is 8. Okay, so what do we do if we have denominators that are either unlike or not the same? This would be called subtracting mixed numbers with different denominators, or subtracting mixed numbers with unlike denominators. We're going to work the problem pretty much the same way as we did when we were adding mixed numbers with unlike denominators, except the only difference is we're going to be subtracting these numbers. We're going to be taking away a value. Okay, I'm going to start with my whole numbers. I have a 42 and a 17, and so I'm going to subtract 42 minus 17, and I get a new whole number of 25. And then I'm going to look at my fractions. I look at the denominator first to see if they are the same, which they are not. And so then I ask myself, are either of these numbers a factor of the other? I notice that 4 is indeed a factor of 8. And so I can leave my fraction 7 over 8 the same, and I'm going to change my fraction 1 over 4 to a new fraction that has a denominator of 8. 4 goes into 8 2 times, and 2 times 1 is 2. So now I have a new fraction of 2 over 8, and I'm going to subtract that from the fraction 7 over 8. When I do that, I get the result of 5 over 8. And so I just combine that now with my old whole number of 25, and my final answer is 25 and 5/8. And lastly, we want to just estimate with mixed numbers. Estimating with mixed numbers is just like I showed you guys before with estimating with regular fractions. We're always going to round everything to either 0, 1, or 1/2. And so we are looking at the problem 2 3/4 plus 1 9/16. Again, this works the same way with subtraction. We're going to separate the whole number from the fraction. And so we have a 2 plus 3/4 plus 1 plus 9 over 16. All right, so I notice that 2 and 1 are already whole numbers, so I don't need to estimate those. 2 is closer to 2. 3/4 is closest to 1. 1 is close to 1. And 9 over 16 is close to 1/2. I add all 4 of those values together, and I get a total of 4 1/2. This concludes our lesson on 4.6, adding and subtracting mixed numbers.